The Clostridium, the Helicobacter pylori. Previously it was called as a Campylobacter. Okay. Later on, Helicobacter. He was a scientist. He got a Nobel Prize for this microbe. It is not a joke to get a Nobel Prize for the discovery. Usually, all microbes, 99.9 microbes, when we eat, they get killed in the stomach. Finish. Stomach acid remove them. Like fire destroys something like a paper. Similar way, the enzymatic and presence of acid. What's the pH of a stomach acid? 2. Correct. Very good. Only pH 2. If you put the pH 2 here, you see bubbles coming up at a very low pH. If you put it on iron, you see the gas coming up. So similar pH is in our stomach. So no microbe is surviving in the stomach. But then sometimes the question comes to the mind, then how infection occurs if all microbes get killed? But sometimes the microbes are so rushed, so many, so unlimited microbes, when the enzymes attack inside, some of them escape. Yeah. Some of them they enter and cause infection. Otherwise, first barrier is stomach. But with this microbe is very dangerous. This microbe is very dangerous. As one of your friends said, he said, this is a human being, this is his stomach, the pH is 2. pH is 2 acid contents. So this is a capability to destroy all the microbes. But once the Helicobacter pylori, H. pylori enter, it has an enzyme, urease. Urease has an enzyme that has what? It has a capability. What urease do? What urease do?
Breaking down urea and water.
What is this structure?
Ammonia.
This is urea, okay?
Yes, sir.
This is the complete form of urea. This is the urea molecule.
Yes.
This is the urea. Forget about Helicobacter pylori. First, understand what is a urea. This is the urea molecule. How we take urea inside in our stomach? From where urea comes? From foods, other things. Foods that we eat. Foods that we eat. This urea is present in your stomach. Present in your stomach. And in the normal process of digestion, this goes to the gut, in the GIT tract, utilize it, finally comes in the urine, and urea comes out. You go pee in the washroom, finish. This is the normal process. This is a normal process. When you take the urea, foods contain urea, it goes to your stomach, digestion occurs, this urea process goes to the liver and change form to urea absorbed, and then finally in the washroom you go, you make urine.
In the same form,
urine. You after even as such, and also the urea that is produced in the urea cycle that occurs in the liver, okay? The urea that is end produced, it goes to the urine and comes out. What is the composition of urine? It's not our topic, but still I am asking this question. What is the composition of urea? What's the composition of urine? Yes, water 90%, very good, and urea, very good, and if it is a nitrogen, then there is a problem, then you are diseased. In presence of nitrogen, presence of protein, presence of proteinaceous substances, presence of epithelial cells, presence of RBC, presence of WBC, then you are infected. No, zero. Nitrate should be zero. WBC is less than 5. Yes. RBC is less than 5. Oh, yes. So there is a, so urea is actually a component. Urea, water, and sodium chloride. Sodium and chlorine. This is a composition of an actual urine. Other things they are very little. So it goes to the urine and finish without causing any problem. Now you have a bacteria present in your stomach. The name of the bacteria is Helicobacter pylori. The whole course changes now. The whole course changes now. How? When this bacteria enters your stomach, the acid tries to destroy it, but it releases the enzyme urease. It releases the enzyme. It releases the enzyme H. pylori, HP. When this bacteria releases the urease, what happens? You see, immediately urease comes and it breaks down urea in the stomach.
Okay.
In the stomach, it forms carbon dioxide plus ammonia. Now one more problem. The same stomach. The earlier case is different. Now, when microbe is here, it releases the urease, the carbon dioxide ammonia is formed. Now it is acid, 0.2. What is ammonia?
Alkaline.
Alkaline, base, very good. Base. And more base is produced in stomach ammonia. Now pH from 2 it shifts to 6, 7, 8, 9. It changes the pH of your stomach. Finish. Your stomach is now no more acidic if Helicobacter pylori is present. Yes, sir.
So this bacteria change the pH of stomach or surround the bacteria by ammonia.
Very good. Not surround it on. What is the benefit of surrounding?
Surround the bacteria for survival.
Wait. Work up your true, but what I want to say in another text. The job of acid is to kill the bacteria. When this microbe releases the ammonia, ammonia is a base. What it causes to the acid? It neutralizes. So when it is around the bacteria, of course now this is the Helicobacter, around it is a cloud or ammonia.
Okay.
Now pH 2 will not affect. In fact, pH gets changed.
Even in the stomach.
Of course, pH new acid is produced. But with this present, this is the reason this bacteria is more dangerous. Do you know why? It is present here in this part of stomach. It is present here,
Okay.
right? It is attached. So when bacteria is attached in this part here, is no effect. Here in this part, when the bacteria is attached, this bacteria will release an urease enzyme. This urease will break down urea and ammonia is formed. This area become now alkaline. This is not now acidic. The pH of this area is now changed. So if infection remains there, within short period of time, it will erode this. Now there is no bacteria will penetrate more and more. It gets favorable environment, protection. And it causes ulcer, a huge ulcer, many problems.
So the answer from the bacteria, not from the acid.
Not from the acid. Bacteria erodes. Bacteria erodes. Why? Because bacteria gets the protection from ammonia. What is ammonia? Ammonia is a base. How base helps? It neutralizes the effect of the pH, of the acid. Because how it neutralizes? It changes the pH from 2 to above. Right? So when acid tries to approach, the ammonia comes on the front. For example, you are going to hit me. If I put this board in front of me, what will happen? It will strike here, right?
Yes.
I am on the safer side. This is the job of ammonia. So it changes the pH of the stomach. And this is called, and now you have a base, increase in pH in the stomach. Why? When increase in pH of the stomach, it gives a chance. It gives a chance of survival. Chance of survival to H. pylori. And this is his job. This is the job of the enzyme urease. Now we have made a test. We have made a test. This is clear now?
Clear.
Last year it was a big board. Where it is? Now, on the basis of this, a test was made. It's called. This is now clear. Clear up to here. On this principle, a test was created. It is called urea breath test. Urea breath test. Based on carbon 13. Based on carbon 13. Based on carbon. So now question is, what is carbon 13? You see this carbon dioxide.
Yes.
This carbon dioxide. It goes. This ammonia protects the bacteria. Now job of this carbon dioxide. It goes to the lungs.
Yes.
And from the lungs it comes out. We inhale oxygen, exhale carbon dioxide. So So this is the carbon dioxide comes out. On this basis, the academicians or scientists, they have prepared a test. They have prepared a test. It's called the carbon-13 test. Usually carbon in the chemistry,
Yes.
it has atomic number 12. What? 12. 12. But we can make number of isotopes on carbon, like carbon 12, carbon 13, carbon 14, carbon 15, carbon 16. By changing its neutrons, not the protons. It is no need to go in the detail. It contains proton and neutron. Here we pick up, this is normal. Now in our case, it is carbon 12. Carbon 12 out. Carbon 12 out. We took carbon 13. I will tell you why. First, we did not select 14, we did not select this. Because these are all radioactive. These are all radioactive. Radioactive are the substances that can cause many problems in the body, okay? This is not, only two forms of carbon are stable. Carbon 12 and carbon 13, these are stable. Stable isotopes of carbon. Only carbon 12 and
13.
God has given us carbon 12. So our cells have carbon 12. So no need to measure it. We know it is carbon 12. So what scientists, they find carbon 13, different carbon, not similar to this. One proton extra. It is also stable. They made a test on its base. They made a test. See here, the above discussed. Urea, CO, NH2, NH2. The way I put it on the board. Water, ammonia, and carbon, but C30.
Yes.
So this is a urea breath test kit. You get it from the market. There is presence of a capsule inside it. That capsule contains urea, but here not carbon 12, it is carbon 13. It is not. This is urea. It is CO. It is NH2, NH2. Huh? This carbon is not now 12. The natural, it is 13. It is 13. And when we took the capsule inside our body, the capsule bursts in the stomach, it releases the urea, but this time the urea contains carbon 13. Carbon 13. It goes to here. This is the urease enzyme, this is H. pylori, carbon 13 and ammonia. Carbon 13 is released, it goes to the lungs, this carbon 13, and it comes out. There is outside a bag. There is a this is called urea breath bag. Okay? You inside the bag, and there is measurement of carbon 13. It gives, if there is carbon 13 present, if there is Helicobacter pylori in the stomach, if you break down this urine, it shows there is presence of Helicobacteria. If you do no change, nothing, no measurement, this means there is no infection. This means there is?
No.
This means that carbon is carbon 12. Because when we take the capsule, we are both having C12 and C13, right? C12 is a natural that we are throwing out. But C13 specific for Helicobacter pylori. If it reacts on it, immediately C13 is released and you measure it. Understand?
Yes.
Immediately this test measurement. And another method. I am the patient with suspected of Helicobacter pylori. They give me one urea bag. Okay. They measure the record. I am only suspect. Now, on the second moment, they asked me to take the capsule. I took the capsule, and again, if first bag and second bag same, no infection. Yalla, go, you are free. If there is difference in the first storage of the test and the second, they say, oh yes, he is having the infection of, because in the first moment, it is carbon 12, okay? In the first bag, when we throw iron, it is carbon 12, normal. After taking the capsule, now I have both C12 and C13. C13 will be produced only if there is presence of urease. Now, if there is no, now you have taken the capsule. Helicobacter pylori is not there. What will happen?
C12.
Only C12. This urea will go straight out and finish out. Finish? Now, what is the principle of carbon this test? The principle is the urea is taken, it goes into the stomach, It's broken down by the enzyme urease. It's broken down by the enzyme urease. It produces the carbon dioxide and ammonia. Full stop. This is the principle of the test. Khalas? Very simple test. Finish. Any questions here?
This capsule contain ammonia. The capsule contain ammonia.
Capsule contain urea. Capsule contain urea. Urea is made up of carbon and ammonia. So you are taking the urea capsule. It contains both ammonia and carbon dioxide. That is this is the molecule of urea, containing both ammonia and carbon. This carbon dioxide is here by the action of the urease enzyme and ammonia. Fine. Any other question here? Now culture. A very simple culture for Helicobacter pylori. You need the molar intron acknowledged in the blood, but next morning you have to remove the colony. You have to I'm sorry, not remove, it's another place. And here you see the thin white cloud colonies of this bacteria. Colonies are tiny to medium size and transparent. Transparent colony you will find on the Helicobacter agar. Helicobacter agar. Finish?
So how it's isolated? Using what material?
It is a Helicobacter agar modified medium. This medium is particularly made for Helicobacteria.
Yes, I mean what we use to make it very specific for each one.
This is not special. If urea breath test comes positive, you took a sample from the stomach and culture on this media and you see this type of colonies.
This is specific for.
Urea breath test is the most specific. But this media particularly prepared for Helicobacter. This media. It will not allow other microbes to grow.
Yes, this is what I'm asking.
Yes.
What I'm asking. Why this?
It's a selective media. You see?
Yeah, what the substance that you use to make it selective?
Okay, you mean what are the additional substances added to it?
Yes.
Nothing, there is no nothing. I have not gone through this technology. You can find it on the internet. But I believe that it may contain, you see the some content of the urea, this media. Okay?
So transparent colonies.
Transparent colonies, that's it. Transparent colonies. Because this medium actually is a Helicobacter agar modified medium. Modified means something has been added.
Yes.
And I strongly believe that it may be presence of the urea. Because urea is a target for this microbe because it contains this enzyme. Which other microbe has a urease enzyme? Proteus. Proteus, it causes the kidney stone. If Proteus goes to your kidneys, then it produces a urease enzyme and forms the base and calcium reacts and it can form the kidney stone inside your body. Any questions here? Now salmonella. Boys, for the salmonella and typhi and the paratyphi. Now samples depend. In the first week you need blood. In the second week you need serum. In the third week and fourth week you can use stool and urine. You had a lecture on the salmonellosis?
Yes.
So you are aware about this?
Yes.
No need to make explanation. Finish. It's a gram-negative bacteria. It is a rod-shaped flagella and catalase positive, oxidase negative. Okay? Flagellated bacteria. Salmonella typhi, flagellated bacteria. Yani when it is flagellated, this means it is motile. It's a gram-negative and its specificity depends. Why it is blood, serum, stool and upon the stages of the which is infection. Now culture. When you culture this in the blood bottles, salmonella is suspected microbe, you take a blood sample and culture it within 1, 2, 3, 4, 5, 6, within 7 days you will get the results. And if you culture it in the McConkey agar, non-lactose fermenter. What's the McConkey agar? Differentiates lactose fermenter and non-lactose fermenter. Differentiating media and also selective media. It favor only gram negative. It will never favor gram positive because it contains bile salt. So salmonella infection, you can have a chances to take the test sample. At one stage you need the blood for blood culture,
Serum.
other time you need the serum for withdrawal test and stool and for other molecular work. Okay. In the blood culture, you take the human blood from the patient, put in the culture bottle, and wait. Sometimes 3 days, sometimes 4 days, until the turbidity in the blood culture occurs. What's the blood culture? It contains a media, similarly glucose, amino acids, minerals. Extra it contains the sheep blood. 5% of sheep blood in these bottles, and then you take a syringe from the patient one and inject directly into this bottle. Shake the bottle, keep it in the incubation period for 3 days, 4 days, 5 days, and if you see the change in color in the blood, some opaque structures for you suspect it is salmonella. Then you go for another test, then another test. One more test is XLD. This is the special media for salmonella, because salmonella has a capability to produce black coloration. It produces the hydrogen sulfide gas. Why it produces? Because yes, it breaks thiosulfate. Thiosulfate is a component of XLD medium. So boys, two cultures, blood culture and XLD medium. In the blood culture, you need to see opaque when the presence of bacteria, maybe 2 days, 3 days. But this here, it produces the black coloration. When you see all these black spots, you mean that salmonella is present. It has broken down the thiosulfate into hydrogen sulfide. Hydrogen sulfide is a gas. It reacts with iron and produces black color. Without reaction of iron, it will not produce. Okay?
Okay.
Fine. Now withdrawal test. What is the withdrawal test? Tell me about this bacteria.
Serum secretion bacteria. H antigen withdrawal.
Good. Boys, consider this is salmonella typhi. Right? It has a number of strains reservoirs. We have salmonella typhi, we have a paratyphi, okay? Paratype A, paratype B, okay? This is the salmonella bacteria, okay? This is called, it's cell membrane. No, this is the membrane, okay? And this flagella, okay? And sometimes it have a capsule-like covering. Okay. Here it is called which antigen? Flagella, which antigen?
H.
Very good, H. And this, which one? O. And this capsule?
VR.
VI or K?
Yes. It is called VI or K or sometimes C or sometimes C. Forget about this. Because why forget about this? You had a lecture.
Yes.
Why not C considered? Why not this VI is considered in the test?
Because a lot of them have, a lot of bacteria have this one. Not special.
Yes. Some in salmonella when it causes, sometimes it expresses this. It's a mood of the bacteria, but mainly is O and H. O for covering of the microbe and H for flagella. So withdrawal test is test of the serum. Test of the serum to find the antibodies against O and H. You see this flagella H antigen, somatic O antigen, and the capsule. So what is the withdrawal test? Withdrawal test is a biochemical test that we need do to confirm the presence of salmonella and the paratype. It measures the measurement of O and H agglutinin of typhoid and paratyphoid. O antigen for salmonella typhi for somatic is body cover, and H antigen for flagella. This is H antigen for salmonella para and para B. Why not we check O? is why we not check the salmonella type? Why we did not check O antigen for para A and para B?
Doesn't have symbolic.
Why we check O antigen, H antigen of the typhoid, salmonella typhi. But when we talk about the para, we check only H. Why?
Doesn't have symbolic.
Why not O?
Doesn't have symbolic.
No, remember. We never check, always remember this one, note it out. We never check the O antigen of the salmonella paratype because O antigen of paratype has a similar one protein. It is called a factor 12 that resembles with the salmonella type. The paratype has O antigen, salmonella has O antigen, but the protein factor 12 present in the paratype, it is similar to that of salmonella typhoid. So sometimes if you check, it may give the wrong result. It will cross react. It will cross react. Same antibody, same presence. So remember, O antigens of salmonella paratype A and B are not taken. Why are not taken? They will cross react with salmonella type O antigen. This is salmonella type, this is paratype. O and H. Here also A and H. But this O and O are paratype and this it is similar. Which factor 12 protein? It is similar in nature.
Why you use it with the type? It is similar also.
What?
Why we use O antigen for the type? It is similar to
No, paratype we are not. It is similar to that of this. Paratype is similar to that of.
And also type is similar to.
No, it is only the part of this. It is similar to that of that. No, then it's not result. It is equal to this. The protein sequence of paratype is similar to that of typhoid. This is very clear difference. Because if you say like that, then O become invalid. O became invalid. O became invalid like that. Okay, so what is the principle of withdrawal test? The antibody present in the serum, it will react to the antigen either O and H and gives a visible agglutination.
So we do this only in the second week. Only in the second week we can do reader test.
From the actually the withdrawal you can do only when there is presence of antibody. Now it depends. In the end of the first week, antibody can appear. In the second week, it can appear. This is the reason the salmonella test, whenever you are suspecting the patient with salmonellosis, you are suspect salmonella typhi, you need to do test within 3 to 9 days, twice. Because antibody will not present the first day. It will take at least 2 days, 3 days to appear. This is very important for the antibodies. So, this is the slide test. There are two withdrawal tests we do in 2 types, okay? Slide test and tube test. Withdrawal test is performed in 2, in slide test and tube test. In the slide test, O antigen, H, para A, para B. Negative control, positive control. You see the antigen is here?
Yes.
Color. 1, 2, 3, 4. Blue color stands for? Red color stands for? Yellow color stands for? Green, para A. And green color stands for?
pH.
These are the antigens. And this button on in the horizontal position, it is a positive control. What is the positive control? Positive control means already prepared the reaction of antigen and antibody. Usually we use gold standard blood from serum. We create this. It is already positive. So what you will do first? You will place 1 drop of positive control on a reaction slide, direct here.
Okay.
And in the second, you will draw 1 drop of normal saline only, isotonic normal saline here. So these two finish, and pipette 1 drop of serum. Now we will take 1 drop of serum. 1, 2, 3, 4. We put 4 drops of serum. Serum from the patient.
Yes.
Now you are putting up the
Antibody.
antibody. And finally, add drop of Vidal test suspension on the when you took this Vidal test first here and here. Then finally, add 1 drop of O, 1 drop of OH, O with here, H here, AH here, and BH here. Blue color here, green color here, red color here, yellow color here. Okay? And then, yes.
Again, we drop each one or
In the here you put normal saline,
no.
and here also
We see it is not saline.
normal saline. Then you put the drop of antigen. Okay? Antigen, already prepared antigen. And when you put the antibody in serum here, it will react. But here, no reaction, because you did not put serum here. In the slide number 2, in this circle, NC, negative control. Serum should not be added here. In these slides, you put 1 drop of serum, 1 drop of antigen. Then you wait for clumping. Then you wait for, this is the principle. If patient serum contains the antibodies against O and H, it will react and form clump or aggregate. This is the principle of Vidal test. Any question here? Clear?
Yes.
Any other question here? So here, negative control means only normal saline, isotonic. You put a drop of normal saline here, and you will not put serum. You will not put serum, but you put the reagent. You put the reagent, either O or H. At least one you put here. Similarly here, in the positive control, you have a serum drop as well as it is already prepared, goat serum already in the vial. You put the antigen, it will show the immediate reaction. Because this positive control, this means already antibody is ready to react with the antigen. In these 4 slides, you need only 2 things, the serum and antigen. In the 4 slides, O, H, AH and BH, you need only 2 things, the serum and antigen. In these 2 slides, you need normal saline first, then here no serum, only reagent, otherwise it may also react. So we need to clear from positive control and negative control. Okay?
Okay.
This is called the
Slide test.
slide. And slide test is qualitative test. You did not ask me what is slide. Slide test is a qualitative. It does not give the number. Immediately, within seconds, within a minute, under the microscope you will say whether there is typhoid infection, yes or no. Then there is one more test. You see then, you mix the contents. No need to write this in the exam. Identify the slide. You will say it's the Vidal test. Write in a principle for a particular test. You will say if the patient's body or a serum contain the antibodies, that antibodies have a capability to react with the antigens.
Yes.
Respect to antigens. If you mention these 4, much better. Okay? React with the antigens in brackets, O, comma, H, AH, and this. No need to write in the blue, red in the example. This is in the black. And it will react, and the antibody react with the antigen and give the visible clumping or agglutination. Fine?
Yes.
Clear this test? This is called qualitative. There are no numbers. 1:60, 1:100, 1:200, whatever, nothing like that. So then, to confirm one more test, it is called standard tube test. This is an valid test. This is actual test of typhoid. But again, this may, as its Vidal test has negative features, critics, demerits of the Vidal test. It may give false result, both on the tube test as well as the slide test. Why? Very simple. Because of immunization or because of past infection. It can give the false result. So culture is the exact test. Sometimes Vidal test gives you false result. You found the clumping, but it may be a false. It may be a why? Either of immunization or
Previous infection.
previous infection. Yes. Either of these or that. make this, because like this way you will not understand. I will make it very simple to make understand what is standard tube test.